Hi guys, and welcome to lesson 5 on sequences. The title is Sum to Infinity, and here is your competition. Okie dokies. Right, consider this sequence, okay? So, sum to infinity, adding up until we get to the biggest term you could ever think of. Okay, so we know this sequence will go on and on and on and on. So what is happening to their numbers? The numbers are getting bigger and bigger and bigger and bigger. So if we were to add up all the values, the sum will just get bigger and bigger and bigger. We call this a divergent series, okay? A divergent series or a divergent sequence. Because the sum does not go towards a finite number. It will just get bigger and bigger and bigger. Write this down, please. Divergent sequence or series. Okay, well, let's look at now this next sequence. Okay, so this next sequence, what is happening here? Well, you can see we're dividing by 2, so it's a geometric progression. But each time the number is getting smaller and smaller and smaller. The numbers, in fact, will eventually get so close to 0 it almost becomes 0, but never does become 0. We keep on halving and halving and halving. This is called a convergent series. And what we mean by that is that all these values will converge to a specific number if you added them all up together. So we say that this series will have a sum to infinity. Okay, so you keep on adding, but what you're adding is so tiny, it's not going to make any difference. Okay, now let's think to yourself, what would this series add up to if you added them all up and you went all the way to the smallest value you could think of? Have a think about that. Okay, we'll look at it later on what the actual answer is. So to make a series convergent, what do you think R has to be? What do you think R has to be? In this case, R was 2 and it was a divergent series. This one, R was a half and it was a convergent series. Yeah? Would this be a convergent series? Where R is negative a half. Will that also converge to a value? So both of these are convergent series. You can see here R is a half and here R is negative a half. The condition of R for it to be a convergent sequence is this. A GP converges if the modulus of R is less than 1. Yeah, the modulus of R here is a half. The modulus, the positiveness, is a half as well. The modulus of negative half is a half. So both of these R's, the modulus is less than 1, so the series converge. Write that down, please. Now, if a series does converge, then we say that the sum to infinity, this is called sum to infinity, is A over 1 minus R. Now, in the book, it explains that, and I'm going to have a go at explaining it to you now. So, why does the sum to infinity, this is what I'm trying to explain to you now, okay, why do you get this formula? So, a little bit of hard maths now, guys. Right, now, we know that the sum to n is this. You might want to skip this. You don't need to know this proof. So this is just for your interest if you want this. You can skip it if you prefer. Okay, so we're looking at when n gets as big as possible and the modulus, because remember, this is only true if the modulus of r is less than 1. So as if we look at r to the n, what happens when n goes to infinity? Okay, what does this tend to as n tends to infinity? Okay, so for example, let's say if we had a half for r. So a half to a massive number. Okay, half to, let's say, 1 million. Yeah? Well, if you put that on your calculator, you're going to get a tiny number. And as this power gets bigger and bigger and bigger, the whole value will get smaller and smaller and smaller. And we can say r to the power of a huge number, i.e. r to infinity, will tend to naught as n tends to infinity. That's what this explains here. Okay, so if we think now, what happens to the sum to n terms as n tends to infinity? Well, you can see this bit here is going to tend towards 0. So you can see how we get this formula. If that's going to tend to 0, you've just got a on the top and 1 minus r on the bottom. Okay, that explains on page 73. If you want to look at that explanation again, you don't need to know it for your A-level. It's just a little bit of extra. Okay, so what are we going to look at now? We're going to look at this sequence. So I asked you, what do you think this converges to? Okay, so we keep on adding smaller and smaller and smaller values. Right, well, A is 1 and R is a half. Yeah, we're timesing by a half from one term to the next. So this is what I will get for my sum to infinity. So I've got 1 on the top, half on the bottom, so it will converge to 2. And that makes sense, doesn't it? Yeah? Because you've got 1 3/4 up to here. You keep on adding and adding and adding, and it will eventually converge to a sum of 2. The sum to infinity. Okay, what about this one, where we've got a negative a half for my common ratio? I'm timesing by negative a half for my common ratio. Will that sum to infinity be bigger or smaller than the previous one, which was 2? Have a think to in your head, will this be bigger or smaller? Well, let's find out from the formula. This is the formula we're going to use. We know A is 1 and R is negative a half. So I've got 1 divided by 1.5 or 2/3. So it makes sense, because I'm taking away terms as well as adding terms, that this sum to infinity, 2/3, was less than this sum of infinity, which was 2. Okay, so another question for you. This is question 26. Okay, in the book, let's just find question 26. I'm just trying to think what page it's on. Question 26. Okay, so guys, this is question 26 on page 110. Okay, it's the review one. Okay, so have a go at it yourself if you're feeling confident. Otherwise, watch what I'm doing. We want to show this. So a GP has a first term 4 and sum of the first 3 terms is 7. Okay, so we've got the first term 4. The next term will be 4r, and the next term will be 4r squared. First, second, third term. So this is the sum of the first 3 terms. And we know, we're told in the question, that that is 7. So I've already got here, haven't I? All I've got to do now is put it into the correct order, take 7 from both sides, and I've done part A. Okay, part B. Find the 2 possible values of R. Okay, well, I can see it factorizes. Remember, you can use your calculator to factorize quadratic expressions, and I want you to use your calculators, but you should still show your method to the examiner. Your calculator just shows that you get the right answer. It's just a checking mechanism. Right. Part C, you're told R is positive, so we're going to use this one here. And it says find the sum to infinity. Well, this is the formula for the sum to infinity. So you've got your first term is 4 over 1 minus a half. So you have 8. Okay. So that's that question. Not too hard, but a nice one to go through. Well done if you did that on your own. Right, another question now, which I'd like to do. So turn to page 27, please, in your book, the same page, page 110. Okay, so you've been given 4th term, 5th term, 6th term, and it says to find x and r, and it's a geometric progression. Okay, have a go at this first and then check your answer. Right, we know that R would be the 5th term divided by the 4th term, which will be the same as the 6th term divided by the 5th term. Okay, and if I just rearrange that, I will get 9 equals x squared plus 8x. So I've got my quadratic, which will hopefully factorize. You should just be able to spot this one. So I've got x equals -9 or x equals 1. Okay, in each case, it doesn't tell me if these are positive or not in the question. It just tells me that there's 2 possible values for x, and therefore there'll be 2 possible values for y. So what are those values? Well, if x is -9, okay, let's just see what we get for this sequence. If x is -9, I will have that. And so I can see, remember this isn't the 1st term, this is the 4th term, but I can see R will be 3 divided by -9, or -1/3. Or I could have done R is 1 over 3, okay? The term divided by the previous term is R. Okay, so this is when x is -9. What happens when x is 1? I have this, this, and this. So you can see R is 3. I'm timesing by 3 from term to term. Okay, right, now it says, given that the sum to infinity exists, find A. So let's just recap what our answers were before. When x is -9, R is -1/3, and here R is 3. Right, so if it exists, we know it only exists if the modulus of R is less than 1. So when is the modulus of R less than 1? Is here, when R is -1/3. Here, R is 3, so this will not have a sum to infinity, because we can see that when R is 3, the sequence is just diverging. It's getting bigger and bigger and bigger. When R is -1/3, the sequence is getting smaller and smaller and smaller. this was -1. Sorry, a mistake there. Okay, so find A, find the first term. Well, the first term, I've got the fourth term. I know the fourth term is equal to x. I know this is the fourth term is -9. And I know the sum to infinity exists. So I know sum to infinity is a over 1 minus r. Now, I want to find A and I want to find the sum to infinity. So I can't find A using this formula. I'm going to have to do it from here. Now, I know the formula for the nth term is this. So my fourth term will be AR cubed. And I know my fourth term is -9. I know R is -1/3, so let's put that in. So I know I get this equation here. So if I put that into my calculator, I can see I get A to be 243. Now, you guys might have found an easier way to do that, which I've just realised myself. The easier way, I'll find the sum to infinity in a second. I've got these terms already. This is the fourth term, fifth term, and sixth term. So to go back, I could just go back third term, second term, first term, first, second, third. I could just go back to find my first term. So all I have to do is, this way I'm timesing by -3rd. So if I go backwards, I'm just going to divide by -1/3 or times by -3. So I would get 27, -81 and +243, just timesing by -3. Okay, now we can find the sum to infinity. The sum to infinity will just be using this formula here. Sum to infinity is A over 1 minus R. So 243 divided by 4/3. I'll just quickly do that on the calculator. 243 times 3 divided by 4 will equal 182.25. Okay, if you spot any mistakes, obviously always deliberate, please email me. First to see a deliberate mistake will get a prize. If I've corrected my mistakes on the way though, that doesn't count. Right, so what have I set for you guys? This is what I've set for you. Okay, exercise 3A, all questions plus some optional extra challenge work for those grade A stars and grade A's. Have a lovely day.